Hello learners, I am Dr. R.B. Malati, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, Bhilai. I welcome you all again to the course Essentials of Surveying, Application and Techniques. In our last class, we learned about chain surveying, which is used to define boundaries, determine areas and create accurate land plans. We talked about how this method involves measuring the sides of the triangles directly without angular measurements, making it suitable for flat areas. We also discussed important terms like main survey stations, baselines and check lines, and how choosing the right stations and baselines help to reduce the errors. We learned how to measure offsets and the importance of accurate measurements and strategic station placement for precise land surveys. Okay, now let us continue by discussing more important concepts in chain surveying. Let us first talk about the field books. They are essential tools for surveyors. A field book is a small notebook about 20 cm by 12 cm that opens lengthwise. It is used for writing down measurements and making sketches during a survey. There are two main types of field books, the single field book and the double line field book. Single line field book. This type has a bold red line running down the center of each page which represents the chain line or survey line. The distance measured along this line, called chainage, are written directly on the red line. It is a good option for large scale surveys where you need to record detailed measurements. Now, the second one, that is the double line field book. This one has two blue lines about 1.5 to 2 cm apart, running down the middle of each page. The distance or chainage are written between two lines. This type is great for regular everyday surveying tasks. In both the single and double line field books, you will record offsets, which are distance measured perpendicular to the chain line. If the offset is to the right of the chain line, you write it on the right, and if it is to the left, you write it on the left. The space around the single red line in the single line field book or the columns in the double line field book is used for sketches and symbols to mark important details. Now, let us discuss more topics related to the field books. Okay, and let us talk about how to book field notes in your field book. Think of it as a step-by-step guide. When you start a chain line, you will jot down some key informations at the bottom of the page and work your way up. Here is what you need to record. The first is the chain line name or number. The second is survey station name or number. The third is station mark symbol denoted as delta. This triangle symbol denotes your station mark. Fourth is direction of the survey lines and the fifth is the initial chainage. So, after you record, you move along the chain line and you will enter all distance on the center line or on the center column of your field book. Offsets, which are the distance perpendicular to the chain line, are noted down to the right or left of the column depending on where they are on the ground. Next, to these offsets, you will draw little sketches to help the draftsman draw them correctly later. If you come across any linear details like roads, footpaths, fences or boundary lines intersecting the chain line, you will enter the chainage of these intersection points in the column and sketch the direction of these details. When you reach the end of the chain line, make sure to enclose the final chainage in the triangle symbol and neatly write down the name or number of the station and the chain line. If you have got any tie or subsidiary stations along the chain line, indicate them with a circle or oval around their chainage. This organized way of booking your field book notes ensure everything is clear and easy to follow, making your survey work much smoother. Now, let us see the tips for the chain surveying. Here, I am giving some handy tips to keep in mind when you are booking field notes for a chain survey. These guidelines will help to ensure your notes are accurate, clear and useful when it is a time to plot out the survey back in the office. First come the one page per line. Here you should make sure each chain line or tie line gets its own separate page in the field book. This keeps things organized and easy to follow. Next is a face forward. Always face the direction of chaining while you are booking the notes. This helps keep your observations and recordings consistent. Next is the record immediately. Don't rely on your memory. Write down all measurements as soon as you take them. This way, nothing gets forgotten or mixed up. Next, be thorough and neat. Your notes should be complete, neat and accurate. Include all the information a draftsman will need to plot the survey later. Next is clear numerals. Write numbers clearly and legibly. Avoid any overwriting to keep things clean. Clean sketches. Any sketches of detail should be neat and easy to understand. Then quality pencil. Use a good quality pencil for recording your entries. It makes a difference in the clarity and durability of your notes. Then keep it clean. Treat your field book like an important document. Keep it clean and tidy. If you make a mistake, just code it out and write the correct entry above it. If the entire page is wrong, cross it out and mark it as cancelled. Make a note of the page where the correct readings are recorded. Finally, complete record. A thorough record of the chain survey should include a general layout plan of the lines, detailed information about the lines, the date of the survey, a page index of the lines, names of the surveyor and their assistants. So, by following these tips, you will ensure your field notes are well organized, accurate and ready for use in the office. Now, let us see the equipments you will need for chain surveying. Here are some handy lists to get you started. A 20 meter or 30 meter chain with arrows is your first choice. This is your main tool for measuring distance and make sure it has got arrows to help with alignment. Next is a 20 meter metallic tape. Perfect for those times when you choose to measure quickly and accurately. Next is the ranging rods and offset rods. These help in marking and lining up points on the survey. Think them as your visual aids. Next, an optimal square or a cross staff for checking the angles and ensuring everything in a straight, and it is true. Next, we have plumb bob. This little tool will help you keep everything vertical. Very handy for ensuring your measurements are spot on. Next, we have wooden pegs. Use these to mark key points on the ground. Then a hammer for driving those wooden pegs into the ground. A field book. Keep all your notes and measurements in one place. It is your surveyor's diary. Next is 2 good quality pencil. Always have a backup just in case one breaks or runs out of a lead. Next is a pen knife, handy for sharpening pencils and general tasks. Now let us understand the steps for fieldwork in chain surveying. The first step is reconnaissance. Before you do actual survey, it is important to do the step called reconnaissance. It is like getting an idea of the area where you will be working. Here is what you do here. Step 1 is a preliminary inspection. Here, walk around the site to get a feel of the ground. This will help you to decide where to set up your survey station and how to lay out your chain lines. Next is a check visibility and accessibility. Make sure all your survey stations are visible from each other and that chaining will be straightforward. Then create a key plan. Sketch out a basic map showing boundaries, main features and where your chain lines and stations will go. Add arrows to indicate the directions of your chain lines. Marking stations. Once your reconnaissance is complete, it is time to mark your stations so you can find them easily later on. Soft ground. Drive in wooden pegs so they stick out a bit above the surface. Next, if it is on hard surface, use nails or spikes that are flush with the ground, or sometimes dig a small hole and fill it with cement mortar to mark the station. And if you want to make a permanent marker, that is for long lasting marks, embed a stone in the ground and fix it with cement. Also, jot down the descriptions and draw reference sketches in your field book. These sketches show key points like gates or pillars and help you locate your stations if the markers get moved or lost. Third step is running survey lines. So once you are done with the preliminary work, it is time to get those survey lines running. Here is how you do it. Ranging. Start by making sure your end stations of the baseline are perfectly lined up. This helps keep everything straight. Next, stretch the chain. Lay out the chain in a true alignment with one end of the starting station. Next is fix an arrow. Place an arrow at other end of the chain while it is stretched out on the ground. Next, walk the line. Stroll along the chain line, taking offsets and noting down any detail points on both the right and left sides. Next, record everything. Make sure you jot down all the chain edges and offsets in your field book. Keeping accurate record is a key. Next is repeat the process. Continue the chaining and offsetting until you reach the end of the baseline. Finally, finish other lines. Apply the same process to complete the other survey lines. Having understood the steps for field work in chain surveying, let us understand the instruments you will need for setting out right angles in chain surveying. These are the tools that will help you to get those perfect 90-degree angles. The first option is cross staffs, and the second one is optical squares, and the third one is prism squares. Let us see each of it. First one, cross staff. The cross staff comes in three types: open cross staff, French cross staff and adjustable cross staff. So, open cross staff. It is the simplest type of the cross staff which is commonly used. The common form of the open cross staff consists of four metal arms with vertical slits for sighting through at right angle to each other. The head block is fixed to the top of an iron-shod wooden staff which is driven into the ground. Picture it as a wooden staff with a head block on top which has four metal arms with vertical slits. You use these slits to sight right angles, and these open cross staffs are used for the followings. First is finding the foot of the perpendicular offset, setting out a right angle. Let us see one by one, that is finding the foot of a perpendicular offset. So, for doing this we have to undergo certain process. First is hold the cross staff vertically where you expect the perpendicular to meet the chain line. Turn it until one pair of the slits point to a ranging rod at the chain's line's end. Look through the other pair of slits to see if the point you want to offset to is bisected. Move the cross staff along the chain line until the slits bisects a point. Always keep the cross staff vertical. Next is setting out a right angle. The process here is hold the cross staff vertically at your point on the chain line. Turn it until a ranging rod at either end of the chain line is in sight through one pair of slits. Fix a ranging rod through the other pair of slits. So, next we have French cross staff. This one is a bit fancier. It consists of an octagonal brass tube with slits on all the 8 sides. It has alternate vertical side slits and on opposite vertical faces, windows are provided. Vertical fine wires are stretched on each of these 4 sides. These are used for setting out right angles. With this arrangement, it is possible to set out 45-degree angles also. And the third, we have adjustable cross staffs. These are more versatile and can set out any angle. They come with a magnetic compass on top for taking bearings. They are good for approximate work but not the most accurate one. So, moving to the next, we have optical squares. Now, if you want to get more precise, the optical square is your go-to instrument. It is a small cylindrical box about 50 mm in diameter and 12.5 mm deep. It has got 2 oblong apertures at right angle and an eye hole. Inside there are 2 mirrors set at 45 degrees to each other. So, let us understand the principle here, and this is the principle behind. The optical square works on the principle that a ray of light reflected from 2 surfaces undergoes a deviation of twice the angle between the reflecting surfaces. So, how to use an optical square? For finding the foot of a perpendicular, place the eye at the eye hole. Look through the transparent half of the horizon mirror to see the direct signal. Simultaneously see the signal through the silvered portion of the horizon mirror after reflection from the index mirror. And for setting out a perpendicular, follow the same steps to ensure your chain line is perpendicular at the given point. These tools will help you to get those precise right angles and you need it in your chain surveying work. Now, let us talk about what you need for a cross staff survey and how to handle the calculations and plottings. Here are the steps for it. First, cross staff. This is your main tool. It helps you to divide the areas into right angle triangles and trapezoids. Next, 2 chains. You will need these to measure the lengths of your baseline and the perpendicular offsets. Next, arrows and ranging rods. These are for marking points and lining everything up. Fourth, plumb bob. Use this for ensuring the vertical accuracy. Now, the calculation of area of the cross staff survey. If it is a triangle, so to calculate the area of the right angle triangle, use this simple formula. Area is equal to base into half the perpendicular. So, if you have a base of 10 meter and a perpendicular of 6 meter, the area will be 10 into 6 by 2, that is 30 square meter. Of course, when you come across with trapezoid, for trapezoid the formula is area is equal to base into half the sum of 2 perpendiculars. Let us say your base is 8 meter and your perpendiculars are 5 meter and 7 meters. So, the area would be 8 into 5 plus 7 by 2, which gives 8 into 6 is equal to 48 square meter. Now, once you have got all your field observation and measurements, it is time to plot them on the paper. So, plotting a cross survey is the next topic. For this, use a convenient scale to make everything fit nicely. Here is a quick example. Start with your baseline. Here, draw it to scale. Next, add perpendiculars, that is, draw lines at right angles from your baseline marking where your cross staff was used. Then, connect points, link the ends of your perpendicular to form triangles and trapezoids. Then, label everything. Make sure each point, line and the area is clearly labeled with measurements. Next, with these steps and measurements, you will all set up for a successful cross staff survey. So, we will see the obstacles you might face during chaining and how to tackle them now. So, when you are out there with a chain and ranging rod, you will face various types of obstacles during chaining. Obstacles which obstruct ranging but not chaining. Second, obstacles which obstruct chaining but not ranging. Third, obstacles which obstruct both ranging and chaining. So, let us see one by one. Obstacles that obstruct ranging but not chaining. These obstacles block your view but don't stop you from chaining. Think of hilly or undulating terrain where you can't see the ends of your chain line from each other. Here is what to do. First, ends visible from intermediate points has to be done, meaning find intermediate points along the chain line where you can see both the ends. Then use these points to keep your chaining accurate. Next, ends not visible from any intermediate point, meaning if no intermediate points give you a clear view of both ends, you will need to use other methods like setting up multiple intermediate stations or using indirect measurements. Next, obstacles that obstruct chaining but not ranging. These obstacles let you see the ends but block the actual chaining. Think lakes, rivers or big ponds. Here is how to manage. Measure around the obstacle, meaning if possible, measure distance around the obstacle to bypass it. Next, use indirect methods, that is, sometimes you will need to use triangulation or other indirect methods to determine distance accurately. So, the third we have obstacles that obstruct both ranging and chaining. These are the toughest because you can't see through or chain through them. Examples include houses, large stakes or dense forests. So, here is a strategy for it. First is aligning around the obstacles, meaning set up additional stations around the obstacles. Next, use auxiliary lines, meaning create auxiliary lines parallel to your main line, measure them and then calculate the necessary measurements to maintain accuracy. So, by understanding these obstacles and how to overcome them, you will keep your chaining accurate and efficient no matter what is your way. Let us see an example of a cross-staff survey. Draw a rough sketch and calculate the area of the field A, B, C, D, E, F, G in hectares. So, the example goes like this. Draw a rough sketch of the following cross-staff survey of a field A, B, C, D, E, F, G and calculate its area in hectares. All distance are given in meter. Step 1 of the solution is sketch the field. Imagine a rough sketch with points labeled A, B, C, D, E, F, G, each forming distinct shapes like triangles and trapezoids. Step 2 would be the calculating the area. So, if you see the area of the figure 1 is a triangle. So, the area will be half into 100 into 25, it is equal to 1250 square meter. And if you see the figure 2, it is a trapezoid. So, the area of the figure 2 is half into 200 into 25 plus 125, that is 15,000 square meter. And if you see the third figure, it is triangle. So, the area of the triangle will be half into 350 by 230 is 4250 square meter. Then the figure 4 is again a triangle and the area of the triangle is half into 100 into 105, which gives 5250 square meter. Similarly, the area of the figure 5, 6, 7 are triangles which will be 11,700 square meter, 26,350 square meter and 7,200 square meter. Step 3, you add up the areas, that is, you identify the total area from figures 1 to 7. When you do that, it comes up to 1,07,000 square meter. Step 4 is convert to hectares. We know 1 hectare is equal to 10,000 square meter. So, the total area in hectares is 1,07,000 square meter divided by 10,000, which yields 10.7 hectares. So, the total area of the field A, B, C, D, E, F, G is 10.7 hectares. Let us walk through another example, that is, plot the following details of a field and calculate its area in hectares and all measurements being in meter. So, the step 1 is find the area of the figure 1. This part of the field looks like a triangle. So, the formula for the area of the triangle is half into base into h. So, for figure 1, the base is 4 meter and the height is 30 meter. So, the area of the figure 1 is equal to half into 14 into 30, which yields 210 square meter. And the step 2, area of the figure 2. Now, figure 2 is bit more interesting. It is also a triangle, but the base and height are a bit more complex. The base is the difference between 54 meter and 14 meter, which is 40 meter. The height is the average of 30 meter and 42 meter. So, the area of the figure 2 will be half into 40 into 30 plus 42, which yields half into 40 into 72, which is 1440 square meters. Now, step 3, that is area of the figure 3. Figure 3 is another triangle with a base of 20 meter and a height 42 meter. So, using the same triangle area formula, we obtain area of the figure 3 is half into 20 into 42, it is 420 square meter. Step 4, it is area of the figure 4. Now, figure 4 is a big one. It is a triangle too, where the base is difference between 100 meter and 26 meter and the height is the average of 50 meter and 80 meter. So, area of the figure 4 is equal to half into 100 minus 26 into 50 plus 80, which yields 4810 square meter. Now, step 5, that is area of the figure 5. Finally, figure 5 is a triangle with a base of 26 meter and a height of 50 meter. So, the area of the figure 5 is equal to half into 26 into 50 is equal to 650 square meter. So, the total area of the field. Now, let us add all this area together, which comes around to 7530 square meter, and converting to hectares, we obtain the value 0.753 hectares. And there you have it, the total area of your field is 0.753 hectares. Now, let us see about some conventional signs on maps. Conventional signs, imagine you are looking at a map. It is like a mini version of the earth's surface on a flat piece of paper. The earth is full of all sorts of natural and man-made features like mountains, rivers, roads, buildings and so on. Now, if we try to write out the names of every single thing on the map, it would be very crowded and hard to read. This is where conventional signs come to the rescue. So, conventional signs are standard symbols used to represent different features on a map. Think of them as a universal language that all map readers and markers understand. Let us say there are 10 temples in the area shown on the map. We have two options for showing their location. First one is draw a little picture of a temple and write down the word temple next to each one. So, you had temple written 10 times. This makes a map look messy and crowded. Second option is use a special symbol that everyone recognizes as temple. This symbol is simple and takes up less space, keeping the map clean and easy to understand. For example, instead of writing temple 10 times, you might use a small icon like this. These symbols are known as conventional signs. They are useful because they simplify the map and make it clear without cluttering it with words. Now, imagine if you also needed to show mosques, churches and tombs on the same map. Tapping out the names for each of these words turn your map into a chaotic jumble of text. Instead, you can use specific symbols for each. For mosque, this is a symbol, and for church, this is a symbol, and for the tomb, this is the symbol. these symbols are designed to look like the actual features they represent either from the side view or from the above. So, by using these conventional signs, maps stay clean, neat and informative. So, next time you look at a map, appreciate those tiny symbols. So, here we have it. Let us summarize today's lecture. Today we covered the essentials of chain surveying, focusing on the use of field books for recording measurement and sketches. We discussed how to properly book field notes, the equipments needed for surveying and the steps for conducting field works including reconnaissance and marking station. We also reviewed instruments for setting out right angles and techniques for overcoming obstacles in chaining. Lastly, we practiced calculating areas, plotting surveys and using conventional signs for clear map representation. Thank you. Happy learning.